Assalamu alaikum, dear students. Welcome to my YouTube channel, Math Experts. Students, if you are new here, please do subscribe my YouTube channel, click the bell icon. And if you have any question, you can ask via email in the comment section. We will solve and send to you. Students, first of all, I will share the question with you. The question is, if Z is a complex variable and Z prime denote the complex conjugate of Z, what is the limit z approaches to 0, z conjugate ka square over z ka square. So first of all, z is equal to, if we take alpha a plus iota b, and then z conjugate is similarly, we just make the change of sign a minus iota b. So we will solve this and find the limit of this question. So first of all, the question is, it's very important question and appear in many times in GAT subject, GRE International, and in 221 AJK PSC lecture mathematics exam. So we want to find this one, limit z approaches to 0, mod of z ka square, sorry, conjugate of z ka square over z ka square is equal to what? So for this, let we take z is equal to mod of r e raised to power iota theta. You know that we can write a complex number in this form by using this identity. This is also known as z is equal to mod of r, and using the Euler identity, we can write this cos of theta plus iota sine of theta. Okay, students, where mod of r is modulus, you know that this is known as modulus. Theta is a number between what? Minus pi to pi. Okay, students. So if we take the conjugate of this number, z bar is equal to mod of r, modulus of r, and we call it cos of theta minus iota sine of theta. Okay, students. And if I write it simply, you know that we can write mod of r into cos of minus theta plus iota sine of minus theta, because you know that cos of minus theta is equal to cos of theta, and we can write sine of minus theta is equal to minus sine of theta. Now moving forward, okay ji. Now we have mod of sorry, z is equal to this one, and z conjugate is equal to this one. If I write z conjugate is equal to modulus of r e raised to power minus iota theta. Can we write this? Yes, we can write this in this form. So if z approaches to 0, it's mean that modulus of z approaches to 0. If r approaches to 0, it's mean modulus of r approaches to 0. Now applying the limit modulus of r approaches to 0, mod of z, sorry, conjugate of z ka square over z ka square. I write this modulus of r in the place of z, because you know that we have z is equal to modulus of r, because if we apply here mod of z is equal to mod of r, and here we have cos of square theta plus iota, sorry, plus sine of square theta, which is equal to 1. So mod of z is equal to mod of r. So it's mean that we can apply the limit easily. Now applying the limit mod of r approaches to 0, conjugate of z ka square over z ka square. Limit modulus of r approaches to 0. So here we have modulus of r e raised to power minus iota theta and whole square divided by, here we have modulus of r e raised to power iota theta and whole square. So this modulus of r cancel with this. So limit modulus of r approaches to 0. Here we have e raised to power minus 2 iota theta, and then we have e raised to power 2 iota theta. Now we have limit modulus of r approaches to 0, and we have e raised to power minus 4 iota theta, which is equal to, the limit is equal to minus 4 iota theta. Here friends, you can see we get the limit L is equal to e raised to power minus 4 iota theta. Now here we have a variable theta. Theta belongs to minus pi to pi. From this interval, if we put a single digit, a single number, so we get a different limit. For every value of theta, we get a different value of limit. So it's mean limit is not unique, limit does not exist. It's very important to understand this step. Here we have theta. When we put theta from this interval, for every unique value of theta, we get a unique value of the limit. So it's mean that the limit is not unique. So we can say that the limit does not exist. So it's mean the correct one option is E option, B, in which the limit does not exist. If you have any question, you can ask by email in the comment section. Please do subscribe my YouTube channel. Thank you so much.